Hello, this is Richard Gillespie. Welcome to Perspectives. This is a series of short video clips that I've put together to discuss subjects which are relevant to today's world and try to put them into some kind of overall perspective. This is a supplement to my video on ice ages and climate change. And today we're going to discuss the effect of the planetary cycles, planetary orbit, and its contribution to the occurrence of ice ages. So first of all, these planetary cycles that we experience, they're nothing new. Ice ages are relatively new. We've been having them since the last 5 million years. Started in the Pliocene, then into the Pleistocene. The Pleistocene began 1.8 million years ago, and that's the most well-known period of ice ages, where we had glacial maximums every 100,000 years. In the Pliocene, we had glacial maximums that were not as severe as the Pleistocene, but they were on a 40,000 year cycle. So these cycles correspond to certain characteristics of the Earth's orbit around the Sun. And of course, these characteristics are nothing new. They've been going on since the beginning of the planet. So why do they trigger ice ages now and they didn't trigger ice ages in the past? And the short answer to that is just continental drift. The continents are in the north-south axis, and this prevents ocean currents from traveling around the equator. Ocean currents are forced in the north and south direction, which moves warm water, more moist water up into colder areas. And this is the primary mechanism for an ice age beginning. But let's talk about the obliquity, the angularity, and how elliptical the Earth's orbit is. The most important factor seems to be how elliptical the orbit is. Every 100,000 years, the major planets align on one side of the Sun, and as the Earth comes around, it gets pulled into an eccentric orbit by the gravitational pull of the outer planets. This means that as the Earth goes around its orbit, it's not going around a circular orbit anymore. It's elliptical, and it's more elliptical than it normally is. It's never circular. It's always elliptical, but it becomes more elliptical. And as you go around the ellipse, as the Earth travels around its orbit, it has to conserve its momentum. This is the law of physics that conservation of momentum has to be maintained. And so as the Earth comes around close to the Sun at the epihelon, the velocity of the planet has to increase in order to maintain its orbit. If it didn't, then the planet would go even closer to the Sun. So in order to maintain its orbital path and to maintain its momentum, the Earth speeds up as it gets to its epihelon. If this corresponds to summer, if the Earth's axis is tilted in the right direction, this will be the summertime. And so it means that we'll have short summers and long winters. And this is one of the key factors in the initiation of an ice age. It's not that the climate gets that much colder. It gets a little colder at the beginning, but not much. But all you need is a very severe winter to trigger things where the ice, there's not enough summer to melt the snow, and then snow starts to accumulate in the north, even if it's a little bit. And as soon as that starts to happen, then you get a feedback effect where the continual snow cover deflects heat away from the sun, from the planet, and you start to get into a cold period. And then, of course, as the ice age develops, and it just gets colder and colder until you get into the middle of the ice age, where the climate the temperature really drops. But you don't need that temperature drop at the beginning to initiate the ice age. You only need, it just needs to be cold enough, and the winter has to be long enough, and the summer short enough, so that all of the snow that falls through the winter doesn't get a chance to melt through the summer. And that's how the planetary cycles contribute to the ice age. But this is nothing new, and the reason they didn't contribute to ice ages in the past was because the continents were not in a correct position for ice ages to develop. So without Antarctica at the South Pole, and without ice at the North Pole, and without the continents being oriented the way they are, the planetary orbital changes would not be enough to create an ice age. So that's the orbits in perspective. They're triggers, but they're not causes.